recording. You
Yeah.
said recording?
Yeah, I'm going to start recording, all right.
You got your laptop back?
No, this is a loaner, but it will record.
Oh, okay. So you got a different laptop today?
No, this is the one I've been using. I've been recording ever since I got this one, yeah.
Because you said one of them only record for like 10 minutes.
Yeah, right. That one only lasted a week or two.
Oh, so you did?
Yeah.
Okay.
But this isn't mine yet. This is a loaner they gave me because they didn't have mine ready. They probably had it ready last Friday, but I was on this campus rather than that campus, so
Okay.
Hopefully I'll get it tomorrow.
Okay.
I don't know for sure, but hopefully. Okay. Trying to think if there are any new announcements. I think I've said this, I don't know, it feels like for 2 weeks now. I think I'm back on regular office hours now. Yesterday I had to leave early because we had to go to Jasper to pick up a car, and the guy said he was going to be leaving at 5:30, so we had to leave early. And when we got there, he said, "Oh no, I'm here till 7." Why are we? So it's crazy. But anyway, I think I'm back on regular schedule. So today, I may have to modify a little bit because one student wants to see me right after the 12:15 class gets out and do advising then. So I'll probably have to advise then do my lunch hour, and then do office hours. So but the block is still there. Sometime between 12:15 and 3:15. All that time pretty much I'll be in the office, and sometime I'll be advising and sometime I'll be eating lunch. But it won't last that long. Okay. Let me mark. Good morning. Were any of y'all impacted by that big wreck on I-2059 coming from near Fairfield? Okay.
I saw it on my way, so when I go back, I will be.
You will be?
Mm-hmm.
Yeah.
I saw it.
Yeah.
I may take the road.
Yeah, they did. They said that both lanes were blocked early this morning. I guess it was so major.
Yeah. It's blocked. Pretty much going all by Fairfield.
Yeah.
No one's running it. They're getting off on it.
But even the incoming, was that blocked too?
Just one lane.
Just one lane. Mm-hmm. Okay. So evidently it's approved. They said at 5 this morning when it happened, everything was shut down. All right, Brittany's not here yet. Justin's not here yet. Whitney's not here yet. Taylor's not here yet. Ilsa is here. You're top of the alphabet today. Way to go. Okay. Terrell's not here yet. Jeremy's not here yet. Mike's not here yet. Doc's not here yet. Tywan's not here yet. Kenesha's not here yet. Darius is here. You're number 2 in the alphabet today. Okay. Angel is, well, yeah. Jawan's not here yet. Do you go by Angel or Anhil? Right, okay. Anhil's here. And Chaston's here. So the bottom part of the alphabet is doing much better than the top half, but glad y'all are here. Okay, hopefully some more will be coming. They may be slow coming through Fairfield. All right. We did example 7 last time. Let's see. I think that was all the announcements. Can't think of anything else. We did example 7 last time. We're going to do 8 today, but 8's not given on the slide set. It goes right into inverse functions. So we're going, let's do examples 8 here. Solving a multi-angle equation. Okay? Here is the multi-angle. Well, let me get my pen activated. All right. 3 times the tangent of x over 2 plus 3 is equal to 0. Okay? It doesn't give us any any limitations there. So what do we do first? What would you do first? Help me. How would you go about solving that trigonometric equation? Say again? Did you say factor? You can. Perfectly legal to factor. Okay? And what do you factor? A 3. That leaves you tangent of x over 2 plus 1 equals 0. Okay, now what? Doesn't seem fair, but you can do it. What's that? Factor 1? Yeah, but first what I would do is divide by 3. Which, by the way, then would make it tangent of x over 2 plus 1 is equal to what? 0. It almost doesn't seem fair. You just threw away the 3. You lost the 3. But guess what? 3 is never 0, so it being a factor, it's not going to contribute anything. Now you subtract the 1 from both sides. Okay? And that gives you tangent of x over 2 is equal to negative 1. Second? Okay, wait, okay. This is the argument here. That's not tangent x over 2, it's tangent of x over 2. That's an entity, okay? You could put it in parentheses, that would be a legal move, they didn't, but you could have. It's not tangent x over 2, it's tangent of x over 2. So the next thing we do is undo the tangent, okay? In other words, what angle, when you take the tangent of it, you get a negative 1. Okay? Okay? I'm going to suggest that something should be maybe a pi force. Yes, but it needs to be negative. So then you would do a negative pi force. Okay? Now that's one solution within your place for tangent, one cycle of tangent, negative pi force. So that means that x over 2 is equal to negative pi force, but because tangent has a period of what? Pi. So it'd be plus n pi, right? Any integer you want to put there for pi, okay? Now you deal with the 2. Multiply everything on both sides of the equation by 2. This multiplied by 2, this multiplied by 2, and this multiplied by 2, okay? This 2 goes out, so you're left with x is equal to minus pi halves plus 2n pi. There's your solution. Infinite number of solutions. Minus pi halves plus 2n pi. Okay, and again, what you did, solve for the tangent function first. That was this step. Then figure out what value that angle has to be. That was that step. And then, so the argument of tangent function, solve for that. And then use your either multiply or divide to solve for the variable x itself. Okay? Any questions? All right. Good deal. Oh, let's see if they got the same answer. Okay. Now, strangely enough, they said 3 pi over 4, which was also a correct answer, okay? And then when they multiplied, it became 3 pi over 2.
What is negative pi half?
Huh?
What is negative pi half? Isn't that 3 pi over
Okay. Yeah, well, okay. Negative pi halves is, okay, what did you say that was?
Isn't negative pi halves 3 pi over 2?
Yes, exactly. On the unit circle, negative pi halves is positive 3 halves pi. So that's what I was just getting at. That is exactly the same answer. But why I found it strange is that really what you're doing here is taking an inverse tangent to undo that, and the inverse tangent of minus 1, because inverse tangent is only defined between minus pi halves and pi halves, you should be using negative pi fourths. Okay? But like you say, it's the same value. Negative pi halves is the same as 3 halves pi. So either one of them are perfectly correct answers, because you're multiplying by 2n pi. And when n is 1, negative pi fourths plus 2 pi would then be, negative, when n is 1, negative pi halves plus 2 pi would be 3 halves pi. So yeah, this one's on that one's on this one, okay? It's just a different thing. Yeah. They are exactly the same answers. All right, so that was example 8, okay? Now, we're going to do what I was just suggesting we were going to do. All right, and that's using inverse function. That's what you were doing, whether you thought about it or not, except that we were just familiar with those angles, so we dealt with it, okay? So here's using inverse function. All right, here's your problem. Secant squared x minus 2 tangent x equal 4. There's your original equation, okay? How do we solve that equation? What's the first thing we've got to deal with? Second? I can't. Okay, and what you got to do with that? What's that?
Sorry, I'm just thinking here. It's 1 minus tangent squared, or 1 tangent squared x plus 1.
Absolutely. Okay. And here's what. All right. The problem with this is that you got two different trig functions here. You can't solve for one without having another one messing it up. So the idea here is to get them all into the same trig function. Well, it's real easy to get a secant squared into a tangent squared because of the identity, Pythagorean identity that Ilse just mentioned. It's harder to get tangent into secant because there aren't any identities that go directly that way. So we worry with this one and we make secant squared. You said tangent squared x plus 1 minus 2 tangent x is equal to, tangent x became tax, okay? Tangent x is equal to 4, okay? Now what do we do? Yes, okay? How do you do that? Subtract 4 from both sides. And I'm also going to rearrange the left-hand side. I'll write the tangent squared x first. Then I'll put my minus 2 tangent x. I'll even try to spell it right this time. And now 1 minus 4 is negative 3, and that's equal to 0. Now what? Factor. If we can factor, let's do so. And what's the only possible factorization for tangent squared? Tangent x times tangent x. Okay? Then we look at the sign of the last term, that's negative. So that tells you these two signs have to be negative and positive. Let's put minus and plus. Okay? And what? Negative 3, positive 1. Let's just check it and make sure. Tangent times tangent is tangent squared. plus tangent x minus 3 tangent x. Sure enough, is negative 2 tangent x minus 3 equals 0. Yes, we got it. And now what? Set each of them equals 0. Is that what you said? Okay. That means that tangent x minus 3 is equal to 0, or tangent x plus 1 is equal to 0. The first one, what do we do with that one? Add 3 to both sides, and that gives you tangent x is equal to 3. Now stop and think, is that one of our familiar tangent values? No. So that's why we have to use the inverse function. Okay? And that simply is, to solve for x, you take the inverse tangent of both sides, and that gives you x is equal to inverse tangent of 3. Okay? And you can leave it just like that. Yeah, pull out your calculator, see what it is. But I would, if I were you, I would get in radian mode first, just to make sure. That's probably how they're going to give the answer. And it's just going to be some value, I'd say, between probably greater than 1, right?
Yeah.
What is it?
It's 1.2.
Yeah, okay. So whatever that is, inverse tangent 3 is a perfectly good answer. How about on the other equation? What do we do there? Subtract 1 from both sides, and that gives us tangent x is equal to minus 1. It seems like we've thought about that recently, haven't we? And what does that give us? Say again? I can't hear. 3/4 pi, let's see, does that work? Yeah, 3/4 pi would work, or negative pi/4 would work, either one. So x equal, I'm guessing they're going to do negative pi/4, but I'm not sure, okay? If I could write a 4. Huh? Yeah. Well, part of the reason they did an inverse tangent on the previous one. If they do an inverse tangent here, that's going to give them negative pi/4, because inverse tangents are only defined between negative pi/halves and pi/halves. Okay? Inverse functions have to be 1 to 1, and that's your interval where they're 1 to 1. Okay? Now, and then what you'd have to do on both of these is plus n pi. Plus n pi. Okay. So they did negative pi/4 plus n pi, or arc tangent. I did inverse tangent of 3 plus n pi. Very good. I remind you, after every example in the text, I'm pretty sure of this, they just about always give a checkpoint. And good thing to do, as soon as you're out of class and have free time, try to get and do your checkpoints, just to remind yourself what we did in class. All right, us are doing the problem. Let's clear the screen. Unless you, well, it's too late now. I was going to say unless there's questions. Let's see how they do it. First thing they did was use the Pythagorean identity that secant squared is, we said tangent squared plus 1, they said 1 plus tangent squared, addition is commutative, it doesn't matter, minus 2 tangent x, and then they subtract 4, okay? And then they combined like terms, and they got tangent squared x minus 2 tangent x minus 3 is equal to 0. Same thing we got, and then they factor that with tangent squared, tangent x minus 3 times tangent x plus 1, just like we did. setting each of those equal to 0, you obtain two solutions on the interval minus pi halves to pi halves. Remember, you have that. And this is open interval. Why is it open and not closed interval? Tangent is not defined as the half pi's. You're dividing by 0 there. Can't have an answer there. So it's only an open interval. Okay? The range of the inverse tangent function is negative pi halves to pi halves. And here's your first one, x equals arctangent 3, or inverse tangent 3. And this one will be x equals inverse tangent negative 1. But we know what that is. That's negative pi fourths. Now, if you try doing that on your calculator, it's going to give you a decimal number. It won't give you a number in values of pi. And you probably won't recognize that decimal number as being negative pi fourths. It's going to be a little bit greater than 0.75. I'm guessing about 0.76 or 0.78 or something like that. All right, so those are the only two possible. Well, those are the two solutions within your domain of negative pi halves to pi halves, but then you also have, because this didn't limit you there, you go plus n pi. Dot this here. Okay. So the last step is then finally because tangent has a period of pi, you add multiples of pi, so it's arctangent of 3 plus n pi and negative pi fourths plus n pi. For n is any integer. Okay. You can use a calculator to approximate the value of arctangent 3. You said it was a little over 2. Okay. That's the last example they show, but there is one more in the text. And let's do example 10. Please, I hope you have books and you can look at your book. I don't want to draw that crystal. Okay. It's not a crystal, it's a honeycomb cell. What's that? Okay. Say that one more time. There is another one in that one. Okay. Let me get my copy of that new edition. So you got two more examples, you said. Is that right? But you have it, we'll 5-3. Okay. You first have one with using a quadratic formula, and then you have the surface area of the honeycomb. Okay. So let's do your example 10. Some of you won't have this example. Okay? Find all solutions for this. Sine squared x minus 3 sine x minus 2 is equal to 0. Okay. And it said find this on the interval 0 to 2 pi. So we're not looking for all of them, just all the ones on 0 to 2 pi. Okay. What would be your approach? Okay. If they didn't tell you use quadratic formula, you might try to factor it. But try as you might, you're not going to be able to get that to factor. Okay? So therefore, we're going to need the quadratic formula. Okay, you said find A, B, and C, so let's do that. What's your A? 1. What's your B? -3. What's your C? negative 2. Okay? What do you do with them? Say that again. Okay. What did you say was equal to that? Okay, very good. I couldn't tell if you said x or yes, because you're treating your sine function as your variable now, not the variable x. It's sine x is equal to minus b, which would be, do I need to write it down for anybody? Quadratic formula? Do I need to write it down for anybody? Is the quadratic formula? Okay. So what is minus 3? I mean minus b? 3 plus or minus the square root of, second, you left out the b squared. Yeah. And what's your b squared? Maybe I should write it down. Okay. Quadratic formula. Minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? So, what goes next? Square root of which is, okay, that's 9. Okay, now, it's normally a minus sign there. Minus 4ac. So minus 4 has a minus sign. A is positive, C is minus. You have two minuses, that makes it a plus, which is good news, meaning you will have a solution. Plus, and then you multiply 4 times 1 times 2, that would be 8, right? Divided by what? Divided by 2. 2 times 1. Okay. Now, this gives you 3 plus or minus the square root of 17 over 2. Now, square root of 17 is just a little bit greater than 4. So 3 plus 4 would be 7. Something seriously wrong with this picture. That would be something greater than 7 over 2. That would be something greater than 3 halves. Huh? I know. That's what I'm saying. With the plus there, you get an impossible solution, right? Because sine x cannot be a positive number. I mean, something greater than 1. This would be 3 plus something greater than 4. 3 plus 4 would be 7. Something greater than 7 over 2, that's something greater than 3 halves. Okay? I mean, 7 halves, which is way greater, is 3 1/2 is what I'm trying to say. Something greater than 3 1/2. Sine can't be something greater than 3 1/2. So you have to throw away the plus sign. That gives you an impossible solution. So you have to use, as you said, the minus sign. So that would be 3 minus something greater than 4. Okay? So that's going to be something, a negative number, a little bit greater than 1. So it's going to be negative 1 point something another over 2. That is a legitimate sign value. Okay, because that's greater than negative 1, but less than positive 1. Okay, so that's the one you use. Now, so you can write that if you want to like that. 3 minus the square root of 17 over 2. Okay, that's what your sine x is equal to. So your x would then equal to what? – 3 the inverse sign of 3 minus root 17 over 2. Okay? And whatever that turns out to be, on the interval from 0 to 2 pi, that's going to be some value in the third quadrant, but you're going to have another value in the fourth quadrant that is also that same amount, because that's a slightly negative number. So then you have to do it's not the complement of that, is it? Maybe. You have to take that number and do, that angle, whatever that angle is, and do 2 pi minus that angle. So, let's see how in the world they write that. Okay, they actually figure out what the value is. Okay. Oh, I got it. Okay. Yeah. The inverse sign, when you figure out what that thing is, whatever that turns out being, that's going to give you a negative angle. Because if you remember, sine, like tangent, is defined from negative pi halves to pi halves. That time there's brackets there, not parentheses, because there you count that this is inside that anyway. It's going to be a number over here. That's between 0 and 2 pi, numbers over here. So you have to take this number, add 2 pi to it, and that gives you the number over here, okay? And then you subtract, you do the, wow. Boy, they do this, okay, got it. Okay. You almost, in order to sort of make it make sense to you, you can't just leave the radicals in there. This is a radical and an inverse sign. You have to actually figure out what it is. So if you do the inverse sign of that thing there, 3 minus the square root of 17 divided by 2, get that answer. It's going to be something a little bit greater than, or less than negative 0.5. It'll be negative 0.5 something. Okay? And take an inverse sign of it, you're going to get a negative angle. And they get it in the book, what do you get? Have you done that? Get what? Let me take a look at it. Okay, that's going to be, okay. I think you forgot to divide the 2 digits. What's that? Grading mode. I think you are in grading. Just for now, so I can read it. Tough line. I think I see you there. Now, you have to put one more parenthesis. 3 plus square root of 17. And Only you have to reverse. Yeah, but the thing is, okay, here's what I'm saying. Okay, number one, we threw out the plus here, so that's one domain error you have. You have a plus, right? Okay, and here's what you've got to do. Okay, I don't know if any of the rest of you run into this or not. Okay, yeah. What you have to do is put parentheses around that because the whole thing is divided by 2. The way you entered it was 3 minus the square root of 17 divided by 2. The calculator thinks you only want to divide the square root of 17 by 2. Okay. Oh, you did. Okay. I can see that. All right. And then this parenthesis here comes from the inverse sign. Then you have to open another one there. Always like that 3, and then insert 3. Okay. What you got to do here, that's the thing. Your calculator is opening this for inverse sign. Okay. You have to do another parenthesis for 3 minus root 17. You see what I'm saying? Because this thing has to be, what you were using was this one. You have to have another one for 3 minus root 17, then divide by 2, then close your inverse sign one. That should give you the right answer.
I have to do 3 divided by 2 minus square root of 17 divided by 2.
That's another way to do it. Okay? Either way there would work. Okay? Let me mark Justin here. All right. What's that? No, it would if you'd have put one more parenthesis in front of the 3. That would have worked. Okay. So whichever way you see best. So that gives you a value for x, okay, which is your angle. And that's a negative angle, right? Okay. I'm going to go and turn off the light again because I just have some calculated keys. If you can't do them, I can't see them. Then that makes it easier to board this way. So that gives you an angle, and that angle is negative. Did you get negative 0.5616? That's what the book got. Is that what you got? Negative 0.5616. Oh, that's without the inverse sign. Okay? Then take the inverse sign of whatever you got there.
Yeah, so I got the
Oh, okay, right. Okay, sorry. You're right. Then the inverse sign of that is then negative 9 point. Okay. Okay, wait just a minute. I wrote it down wrong because I wasn't paying attention. Okay. This value here is what I just said. This value in this is negative 0.5616. Negative 0.5616. Okay. Now the inverse sign of that value is negative 5.5963. Okay. Now, by the way, I don't know if you've run into this before, but it is reality. For very small angles, near 0, okay, positive or negative, if you think about what the sine function looks like, this is sort of an aside here. This is Jeremy, right? Okay. All right. If you think about this, the sine function looks sort of like this, right? That first thing of a sine function. Near zero, that's very close to the diagonal line, right? Very close. The slope is 1 at 0. We don't know that, but it is. So therefore, all values near 0, when you're measuring in radians, the value is very close to the sine, because it's almost diagonal line. The y is equal to x. Not quite, but it's close. So any small angle near 0 is going to be very close to the same value. This is sort of not that close to 0, but it's close enough, it's still pretty close. So you'll notice that when you're in radians. When you're in degrees, it's nowhere close. But in radians, that will be the case. If you haven't hit that before, you'll hit it sometime in the future, odds are. Okay. Now, this value x is not in this domain. This value here is not between 0 and 2 pi. So what we have to do is add 2 pi to this, and that will get you in that domain. But that will get you on the 2 pi side of it. You need to come back. If I had drawn my... Let me redraw the sine function somewhere else on the graph. Okay. Yuck. Okay. Let's draw it over here. Here's the sine function. Okay. You had a value here. That was the negative 0.5963. When you added 2 pi, that gave you that value. Now you have to get this value here. How do you get that one? Okay. Well, basically, if you think about it, this value you were given is the negative of your reference angle, right? So when you subtract that reference angle from 2 pi, you get this angle. Add that reference angle to this one, the positive value of that, to pi, and you get this one. So that's why they say it's pi plus the 0.56. Notice not a negative, plus, okay? And the other one is 2 pi minus the 0.5963. So that's why those values are like they are, okay? Those are the two values inside this. This is your reference angle, the negative of that. If you take the positive of it, that is the reference angle. Subtract that from 2 pi, you get one answer. Add it to pi, and you get the other answer. So it's going back to the reference angle almost. It's only that's a negative reference angle, and reference angles are always positive. So does that make sense? That was a little bit trickier problem. I can see why they didn't have it in the previous edition. Okay? So, that was the one not in the old edition, that's the one in the new edition. So, if you have the old edition, you don't have that. Okay? So, what you do is take this angle, they were calling it theta. I don't know why they were calling it, no, they called it x. Okay? And they take the positive value there of this, make that your reference angle, and then your answer is your two answers then, for some reason we're at theta again, I don't know why, I've got theta on the brain here. So your first answer would be pi plus that reference angle, 0.5963, and the second one would be 2 pi minus that reference angle, 0.5963. Okay? That's how they get the two angles. Think about this. this, the answer it gave you when you did the inverse sign was this, because the inverse sign only gives you values of minus pi halves and pi halves. It gave you this one. We were asking for values between 0 and 2 pi. Well, add 2 pi to this thing, and you get that, which is basically saying 2 pi minus this, because that's a negative angle. So that gives you that. Well, if you take pi and add that value, not the negative sign to it, that gives you the second value. Okay? Think of this as 0.5963 as the reference angle. Throw away the minus sign. That's the reference angle. Whatever this value is here, that's the reference angle. Add that to pi and subtract it from pi, which is the same as taking this number and adding pi to it. Those are your two values. All right. Now, yes?
When they say 2 pi, they mean like 6.22.
Say again?
I said, when they say 2 pi, they mean actually like 2 times pi.
2 times pi. It's about 3.28 is approximately. Because pi is about 3.14, right? And if you carry the 4 digits, pi is 3.1416. So you double that, you get 3.2832 or something like that, yeah. So that's approximately the value they mean by 2 pi, yeah, in radians. All right, now we're to example 11 in the new book, example 10 in the old book. And this is another sort of a wacko one, and I don't want to draw the honeycomb. I don't do a good job drawing three-dimensional shapes, okay? So hopefully you got your books or you've got something to look at. It says the surface area S in square inches, now they're giving, of a honeycomb cell is given by this. S is equal to 6HS plus 1.5 S squared times the square root of 3 minus a cosine theta divided by sine theta. That's it. And this is good for 0 less than or equal to theta is less than or equal to 90. All right. Anywhere in the first quadrant. Okay? Now, they give us the H here is 2.4 inches. Okay? Your S is 0.75 inches. Okay? And theta is the angle shown in the figure. Okay? And that's what I don't want to draw, because my picture really looks ugly. Okay? It says, what is the value of theta? What value of theta gives the minimum surface area? Minimum surface area. All right. Well, there's a big problem here. I didn't notice it till now. They're using S twice. Capital S is surface area on the right. Those other two S's are small s's. Those are your lengths of the side, 0.75 inches. So why in the world they did that? In fact, I'm going to put SA for surface area so you don't get it confused. Okay. And you want what value of theta gives a minimum surface area? Okay. Okay. Well, this is just a number. That's just a number. There's where all your variables are there. Okay? Your S here is, that's just a numerical value. So what I guess is probably the best thing to do is plug in those values. I don't know. Let's not plug them in yet. Let's see if we can solve that for theta. Okay? That's going to be a really ridiculous thing to do. So they do plug in the value. Oh, how they solve it? Using a calculator, a graphing calculator. They don't even try to solve it analytically. I was going to say, man, that's going to be a bear to do. So what you have to do is set up in degree mode, because they've told you everything. Well, you don't have to be in degree mode, but their answer they give you is in degree mode. And to me, that's just an exercise in calculators. Okay? If you don't have one, we're probably not going to have a problem like that on the test. Okay? So if I do sneak one in, which I don't think I will, I usually have to check them. I used to own a graphing calculator, but it died, so I haven't had one for years either. So it's that's just a problem with using a graphing calculator. And if you don't want to have one, don't sweat it. Let's go to vocabulary for 5.3. When solving fill in the blank. When solving a trigonometric equation, the preliminary goal is to blank the trigonometric function on one side of the equation. I think I know what word they're looking for, but there may be more than one. When solving let me get out of this book and back into the book we have. Okay. Yes, it's the same vocabulary. Just want to make sure of that. When solving a trigonometric equation, the preliminary goal is to blank the trigonometric function involved in the equation. What would be a good word to put there? The word I would use would be isolate. Get it by itself. Isolate the trigonometric function involved in the equation. In other words, gets it on one side by itself and do everything else. Number 2, the equation 2 plus sine theta equal 1, 2 sine theta plus 1 equals 0, has a solution of pi is equal to 7/6 pi plus 2n pi, and theta is equal to 11/6 pi plus 2n pi, which are called blank solutions. What do you call it when you add the 2n pi to it? They're really picking on terms here. I guess that's what vocabulary is. Okay. By the way, the first one, I think the word they were looking for was isolate. You go back to page 364 or whichever book you have, the first introduction, you'll see isolate is in that first paragraph, italicized. That's the word they were looking for. Okay? And the second one there, and that's the very example not the very example, a similar example, they call those two solutions the general solution. Look at the red print next to those equations, the general solutions. Okay? Again, they're really being nitpicky on terms, which I guess is what vocabulary means. Number 3, the equation 2 tangent squared x minus 3 tangent x plus 1 equals 0 is a trigonometric equation that is of the blank type. Quadratic type. Very good. Number 4. A solution of an equation that does not satisfy the original equation is called an blank solution. Okay? That would be one like we were just dealing with, extraneous solution. Okay? Extraneous solution. So homework exercises here, do any of the odds 5 through 9, any of the odds 11 through 23, any of the odds 25 to 37, any of the odds 39 to 43, do either 45 or 47 or both, any of the odds 49 to 57, 59, either 59 or 61 or both, any of the odds 73 to 79, 73, any of the odds, do either 75 or 77 or both, do any of the odds 79 through 83, do 85, and any of the odds 87 through 95. 95. And try to do 97. That's one that sort of stands by itself. Then there's exploration, 99 is a true false, and the others are think about it or something like that. Any questions on 5.3? All right, let's move on to 5.4. All right. All right, next to the last section in the chapter. Now let's think. Should have probably done this earlier. This class has been pretty good about getting research papers in. I'd say pretty close to half of you, if not half of you, have turned them in. The rest of you, please get them there. The first test, I still have one person who has not turned in the first test. And she hasn't been here in several weeks now, so I don't know if she's dropping or not. But unless I know for sure, I can't return those to you. As soon as I find out one way or another, I can return those to you. Second test, I think 5 of the whatever we left with, we were at 17, and then one person didn't pace. We went down to 16, and I don't know if the other person's going to drop or not. So we're 15 or 16 students. A third of you have turned in test 2.
Can we see those?
Say again? I can't.
Can we see those?
Sure. Yeah. If you didn't turn them in yesterday, this week, I've got them graded. Okay, yeah, you can certainly look at those. All right, so let's move on to 5.4. Okay, from current slide. Okay, we're still in analytic trigonometry. Section 5.4 are going to deal with sum and difference formulas. And believe me, if any of you are going into calculus, which I'm guessing that most of you are, you will be using these a fair amount. Not super lot, but you will be using them a fair amount. So, objective here is to use the sum and difference formula to evaluate trigonometric functions, verify identities, and solve trigonometric equations. That's why we use any of these things, to do one of those 3 issues. Okay? So we're going to start with using sum and difference formulas. We need to start with, what are your sum and difference formulas? Now, I have in one textbook I've used before, they actually showed how to derive these. Boy, what a pain in the neck that was. It would take close to a whole class period to describe one of them, okay? So now they just give them to you, which isn't too bad either, okay? If you have two angles you're adding together, and you're wanting the sine of the sum of those angles, here's how you do it. The sine of u plus v is the sine u times the cosine v plus, same sign as here, cosine u sine v. Okay? That's how you do the sum of two angles. Frankly, if you use them often enough, you get to know them. If you don't use them often enough, write them down, know where to go and look them up. Because it's not worth sitting down and just memorizing, but if you use them enough, you'll get to be familiar. Then, if you do sine of u minus v, you really don't need to come up with a new formula and memorize a new one. All you do is everywhere you saw a v up here, put a minus v in its place. So it's the sine of u times the cosine of minus v. And what's the cosine of minus v? Cosine being what kind of function? What kind of function is cosine? As in even, odd, or neither? Even function. So the cosine of minus v is the same as cosine of v. Cosine of minus v is the same value as cosine of v. So therefore, that doesn't change sign. Plus the cosine of u times the sine of minus v. What's the sine of minus v? Sine is an odd function. So it's minus sine of v, so you put a minus sign in front. So you see if they have the same, they have, for sine of u plus v, then in u minus v, the sign in between is the same, the values are the same. Okay? Now, for cosine u plus v, the sign is the opposite. Now it's cosine u cosine v minus sine u sine v. That's the cosine of u minus u plus v. The cosine of u minus v, then, again, all you do is on the plus side, put in a minus v here. That doesn't change the sign. Put in a minus v here, it does change the sign. So that'll be cosine u cosine v plus sine u sine v. Now, the tangent of u plus v is not particularly easy to derive either, okay? So it's probably easier just to either remember the formula if you use it often enough or look it up if you need it. But here's the deal with that. Sine of u plus v, tangent of u plus v is tangent u plus tangent v in the numerator, divided by 1 minus, opposite sign, the product of tangent u times tangent v. So it's the sum in the numerator, the difference of 1 in the product of the denominator. Tangent of u minus v just flips those two signs. This becomes a minus, and this one becomes a plus. And why is that? Because tangent of v minus v is minus tangent of v, so that changes that to a minus, and tangent of v minus v is minus tangent of v, so it changes that. Because tangent is an odd function also. Now, I can almost imagine someone saying, when will you ever need this? Very seldom. But what we do need it for is how to do your double angle formulas. And you have to have the sum angle and difference angles before you can do your double angle. Okay? So we're going to get to that. But here's example 1. It says, find the exact value of sine of pi 12ths. Well, most of you just plug it into a calculator, right? That's not going to give you an exact value. That's going to give you an approximate value, round it off. Well, pi 12ths is not one of those angles we know. What are those angles that we know? Those are our favorite angles. Remember what they were? Wait, I hit the wrong key. what are the angles that we know the values for? Which ones? Okay, we know 0 and 2 pi, they're the same. Okay? In fact, let's just stay in the first quadrant. Okay? That's the whole cycle. 0 in the first quadrant, what are the angles we know? Pi 6, pi fourths, pi thirds, and pi halves. Okay? That's the first quadrant. 0, pi 6, pi fourths, pi thirds, and pi halves. Okay? We know those. We know every trig function for every one of those. May have to think about it. We'll know those. So what we're going to do here is try to see if we can write pi twelfths as either a sum or a difference of these that we do know. So what I would suggest is writing all these in terms of pi twelfths. That would be 0 twelfths pi, okay? How many would be pi 6? How many pi twelfths? 2 pi twelfths. How about pi fourths? How many twelfths is that? Pi fourths is 3 twelfths, right? Pi thirds is how many twelfths? How many? Isn't that 4 pi twelfths? And pi halves is how many twelfths? 6 pi twelfths. Okay? So here we have 0 pi twelfths, 2 pi twelfths, 3 pi twelfths, 4 pi twelfths, and 6 pi twelfths. Now obviously, you can't get pi twelfths out of adding any of those together. Those are all greater than pi twelfths, except 0, there's nothing to add to it. So now we're going to have to do a subtraction. And I see two possible subtractions we can get to get pi twelfths. What would they be? Exactly. So let's rewrite this as the sine of, you said pi fourths minus pi 6? Is that what you said? Yes. Okay. So what was your sine of the difference angle formula for sine? Sine always started with sine. Sine of the first one, pi fourths, times the cosine of the second one, pi 6, and then you have the minus cosine, I'm going to try to keep it the same way the book said it. I was going to do it correctly, a right answer, but I'm going to try to keep it the same way the book does. Minus, no, I think that's how the book did it. Yeah, cosine, okay. Cosine pi fourths times the sine of pi 6. Okay, sorry I ran out of room there. Can anyone remember what sine of pi fourths is? Square root of 2 over 2. And what's the cosine of pi 6? Square root of 3? 3 over 2, is that what you said? I can't hear well. Is that right? Minus, what's the cosine of pi fourths? Square root of 2 over 2 times the sine of pi 6, 1/2. Okay. Let's multiply those two together. The first two. What do you get? The square root of 6 over 4 minus square root of 2 over 4. So you could write that as the square root of 6 minus the square root of 2 all over 4. There is the exact value of sine of pi twelfths. Exact. Okay? Now, sure, you can plug that into your calculator and get a decimal number. You'll get the same thing as if you do the sine of pi twelfths. Guaranteed. And I guess we must be out of time if I hear things closing. All right. Let me just show you how they did it. And surprise, surprise, they did it a different way. How they did it was the difference of pi thirds and pi fourths. That was 4/12 minus 3/12. Will that give you the same answer? Well, let's see. It's sine of pi thirds, cosine of pi fourths, minus the cosine of pi thirds, sine of pi fourths. And that would be root 3 over 2 times root 2 over 2 minus 1 over 2 times root 2 over 2. And sure enough, it does give you exactly the same answer. Okay? So we will move on to, there is a checkpoint there. We will start next time with example 2.
Can we see our test?
Oh, yeah. Okay, just a second. Let me turn off, start uploading the computer, which will be turning it off first.